In the vast expanse of the cosmos, few names shine as brightly as the German astronomer and mathematician Johannes Kepler. Born on December 27, 1571, in the small town of Walderstadt, Germany, Kepler's journey would lead him to become one of the most influential astronomers of all time. His story is one of relentless curiosity, groundbreaking discoveries, and a profound impact on the scientific world. From a young age, Kepler was captivated by the heavens. The sight of a comet blazing across the sky when he was 6 years old and the shadow of the Earth creeping across the moon during a lunar eclipse when he was 9 left an indelible mark on his imagination. These celestial events ignited a passion that would steer him towards a lifelong quest to understand the universe. Kepler's early life was not without its challenges. His family was of modest means, and his father, Heinrich Kepler, was a mercenary who often left the family for extended periods. His mother, Katharina Goldemann, was a healer and herbalist, whose practices would later lead to accusations of witchcraft. Despite these difficulties, Kepler's intelligence and curiosity were evident from a young age. Kepler's academic journey began at the University of Tübingen, where he studied under the guidance of Michael Maestlin, a staunch supporter of the heliocentric theory proposed by Copernicus. Here, Kepler was introduced to revolutionary ideas that challenged the long-held geocentric view of the universe. The young scholar's mind was set ablaze with possibilities, and he began to formulate his own theories about the structure of the cosmos. While at Tübingen, Kepler excelled in his studies, particularly in mathematics and astronomy. He was initially trained for the Lutheran ministry, but his fascination with the stars led him to pursue a different path. Maestlin, recognizing Kepler's potential, encouraged him to delve deeper into the Copernican system, which posited that the Sun, not the Earth, was at the center of the universe. In 1594, Kepler accepted a position as a mathematics teacher at a Protestant school in Graz, Austria. It was here that he began to develop his ideas about the harmony of the cosmos. Kepler believed that the universe was governed by mathematical principles, and that these principles could be discovered through careful observation and analysis. In 1596, at the age of 25, Kepler published his first major work, Mysterium cosmographicum. This bold and imaginative treatise sought to explain the distances of the planets in the solar system using geometric shapes. Kepler proposed that the orbits of the 6 known planets could be understood by imagining 6 spheres separated by the 5 Platonic solids. While this theory would later be disproven, it was Kepler's first attempt to reconcile the Copernican theory with the harmonious order of the cosmos. Mysterium cosmographicum was groundbreaking in its approach, combining mathematical rigor with a deep philosophical belief in the harmony of the universe. Kepler's work caught the attention of other prominent astronomers of his time, including Tycho Brahe, who would later play a crucial role in Kepler's career. In 1600, Kepler's path led him to Prague, where he joined forces with the renowned Danish astronomer Tycho Brahe. Tycho was known for his precise and meticulous observations of the stars and planets, and his observatory at Uraniborg was one of the most advanced in Europe. This collaboration would prove to be a turning point in Kepler's career. Kepler arrived in Prague with a sense of excitement and anticipation. He was eager to work with Tycho, whose observational data was unparalleled. However, the relationship between the two men was not without its challenges. Tycho was a nobleman with a strong personality, while Kepler was a humble and introspective scholar. Despite their differences, the two astronomers shared a common goal: to unlock the secrets of the cosmos. Despite their differing personalities and occasional disagreements, Kepler and Tycho's partnership was crucial. Tycho's meticulous observations provided the precise data Kepler needed to develop his groundbreaking theories on planetary motion. Kepler was particularly interested in the orbit of Mars, which had long puzzled astronomers due to its apparent retrograde motion. Kepler's work with Tycho was both challenging and rewarding. Tycho was protective of his data and initially hesitant to share it fully with Kepler. However, Kepler's persistence and dedication eventually won Tycho's trust. The two men worked together to analyze the data, with Kepler focusing on the mathematical aspects and Tycho providing the observational expertise. In 1601, the sudden death of Tycho Brahe left Kepler with a wealth of astronomical data and the prestigious position of imperial mathematician. This pivotal moment set the stage for Kepler's most significant discoveries. With Tycho's observational data at his disposal, Kepler embarked on a decade-long quest to understand the true nature of planetary orbits. Kepler's relentless pursuit of understanding led him to formulate his first law of planetary motion. Planets move in elliptical orbits with the Sun at one focus. This revolutionary idea shattered the long-held belief that planetary orbits must be perfect circles. Kepler's second law, known as the area law, described how planets sweep out equal areas in equal times. These revelations revolutionized our understanding of planetary motion and laid the groundwork for a new era in astronomy. Kepler's first law was a radical departure from the circular orbits proposed by earlier astronomers. By analyzing Tycho's data, Kepler discovered that the orbit of Mars was not a perfect circle but an ellipse. This insight was a breakthrough in the field of astronomy, challenging centuries of established thought. Kepler's second law further refined his understanding of planetary motion. He observed that a line segment joining a planet, and the Sun sweeps out equal areas during equal intervals of time. This meant that planets move faster when they are closer to the Sun and slower when they are farther away. Kepler's second law provided a more accurate description of planetary motion, paving the way for future discoveries. In 1619, Kepler published Harmonice Mundi, where he introduced his third law of planetary motion. This law established a precise mathematical relationship between a planet's orbital period and its distance from the Sun. The third law states that the square of a planet's orbital period is directly proportional to the cube of the semi-major axis of its orbit. Harmonice Mundi was a culmination of Kepler's lifelong quest to understand the harmony of the cosmos. He believed that the universe was governed by mathematical principles, and that these principles could be discovered through careful observation and analysis. Kepler's third law provided a unifying framework for understanding the motion of planets, further advancing the field of astronomy. Kepler's work on Harmonice Mundi was not limited to planetary motion. He also explored the mathematical relationships between musical harmonies and celestial motions, drawing parallels between the two. Kepler believed that the harmony of the universe was reflected in the harmony of music, and he sought to uncover the underlying mathematical principles that governed both. Kepler's laws laid the groundwork for Isaac Newton's theory of universal gravitation, marking a pivotal moment in the scientific revolution. His contributions continue to influence modern astronomy and space exploration. The mathematical precision and elegance of Kepler's laws provided a solid foundation for future scientists to build upon, ultimately leading to our current understanding of celestial mechanics. Kepler's laws were revolutionary in their simplicity and accuracy. By describing the motion of planets in mathematical terms, Kepler provided a framework that could be tested and refined through observation and experimentation. His work paved the way for Newton's theory of universal gravitation, which further explained the forces governing planetary motion. Kepler's influence extends beyond the realm of astronomy. His emphasis on mathematical precision and empirical evidence set a new standard for scientific inquiry. Kepler's work demonstrated the power of mathematics to describe and predict natural phenomena, inspiring future generations of scientists and mathematicians. While Kepler's scientific achievements were monumental, his personal life was marked by tragedy and hardship. He faced the heart-wrenching loss of his first wife and son, and fought tirelessly to defend his mother against accusations of witchcraft. These personal struggles provide a poignant backdrop to Kepler's scientific pursuits, highlighting his resilience and unwavering dedication to his work. Kepler's first wife, Barbara Myler, passed away in 1611, leaving him to care for their 3 children. The loss of his wife was a devastating blow, but Kepler found solace in his work. He continued to pursue his scientific research with determination, driven by a deep sense of purpose. In 1620, Kepler's mother, Katharina, was accused of witchcraft, a charge that could have led to her execution. Kepler devoted himself to her defense, compiling evidence and arguing her case in court. After a long and arduous legal battle, Katharina was acquitted, but the experience left a lasting impact on Kepler. Despite these hardships, Kepler's dedication to his scientific work never wavered. In his later years, he continued to make significant contributions to astronomy. His epitome Astronomii Copernicani became a fundamental textbook for the Copernican system, synthesizing his life's work and providing a comprehensive overview of heliocentric astronomy. Kepler also played a crucial role in the development of the Rudolphine tables, which provided the most accurate astronomical data of the time. These tables, based on Tycho Brahe's observations and Kepler's own calculations, were used by astronomers for decades and represented a significant advancement in the field of positional astronomy. The Rudolphine tables were named in honor of Emperor Rudolph II, who had supported Tycho Brahe's work and later Kepler's. The tables included detailed information on the positions of the planets, the Sun, and the Moon, as well as predictions for future celestial events. Kepler's meticulous calculations and attention to detail ensured the accuracy and reliability of the tables. The completion of the Rudolphine tables was a monumental achievement for Kepler. It represented the culmination of years of work and collaboration with Tycho Brahe. The tables were published in 1627 and quickly became an essential tool for astronomers, navigators, and scholars. Kepler's work on the Rudolphine tables solidified his reputation as one of the greatest astronomers of his time. Beyond his astronomical work, Johannes Kepler made significant contributions to the field of optics. He developed an improved refracting telescope design, known as the Keplerian telescope, which used a convex lens as the eyepiece. This design provided a wider field of view and better image quality compared to earlier telescopes. Kepler's work in optics extended to the study of vision and the behavior of light. He wrote extensively on the nature of lenses, the formation of images, and the principles of refraction and reflection. His book, Ad Vitellianum Parallelopomena, published in 1604, laid the foundation for the modern understanding of optics and vision. Kepler's contributions to optics were not limited to theoretical work. He also conducted experiments to test his ideas and validate his theories. His innovative approach to the study of light and vision had a lasting impact on the field of optics and influenced future scientists, including Isaac Newton. In addition to his scientific work, Kepler wrote one of the earliest works of science fiction, Somnium. This imaginative narrative described a journey to the moon and speculated about lunar inhabitants. Somnium was not just a work of fiction. It also explored scientific ideas and concepts, blending Kepler's passion for astronomy with his creative storytelling. Somnium was written in the form of a dream, with the protagonist traveling to the moon and observing its landscape and inhabitants. Kepler used the story to explore the possibilities of space travel and the nature of the lunar surface. The book also reflected Kepler's belief in the interconnectedness of the cosmos and the potential for life beyond Earth. Kepler's work in science fiction demonstrated his ability to think beyond the confines of his time and imagine new possibilities. His creative vision and scientific rigor continue to inspire writers, scientists, and explorers to this day. Johannes Kepler passed away on November 15, 1630, in the city of Regensburg, Germany. His death marked the end of a remarkable life dedicated to the pursuit of knowledge and the understanding of the cosmos. Despite the challenges and hardships he faced, Kepler's unwavering dedication to his work left an indelible mark on the scientific world. In his final years, Kepler continued to work on his scientific research and writings. He faced financial difficulties and political instability, but his commitment to his work never wavered. Kepler's contributions to astronomy, mathematics, and optics were recognized and celebrated by his contemporaries, and his legacy continued to grow after his death. Kepler's groundbreaking work in astronomy, mathematics, and science fiction continues to inspire generations of scientists and explorers. From the laws that govern planetary motion to the principles that guide space exploration, Kepler's influence is woven into the fabric of modern science. Kepler's quest to understand the cosmos has forever changed our view of the universe. His work laid the foundation for our modern understanding of the solar system and the laws that govern celestial bodies. The Kepler Space Telescope, named in his honor, has discovered thousands of exoplanets, continuing Kepler's legacy of expanding our knowledge of the universe. Kepler's approach to science, combining careful observation with mathematical analysis and a search for underlying patterns and harmonies, set a new standard for scientific inquiry. His willingness to abandon long-held beliefs in favor of empirical evidence and mathematical proof was revolutionary for his time and helped usher in the age of modern science. As we look to the stars today, equipped with powerful telescopes and advanced technology, we stand on the shoulders of giants like Johannes Kepler. His tireless pursuit of knowledge and his unwavering belief in the harmony of the cosmos continue to resonate with us today. Johannes Kepler's legacy is a testament to the power of curiosity, perseverance, and the human spirit's unending quest for understanding. In the centuries since Kepler's time, our view of the universe has expanded beyond anything he could have imagined. We've discovered galaxies beyond our own, detected gravitational waves, and found evidence of dark matter and dark energy. Yet, the fundamental laws that Kepler discovered still hold true, guiding our understanding of planetary motion not just in our solar system, but in the countless other solar systems we've discovered throughout the galaxy. As we continue to explore the cosmos, pushing the boundaries of our knowledge ever further, we carry with us the spirit of Johannes Kepler, a spirit of wonder, of rigorous inquiry, and of belief in the underlying order and beauty of the universe. His life and work remind us that the pursuit of scientific truth can be a profound and transformative journey, one that has the power to change not just our understanding of the world around us, but our very place within it. Kepler's influence extends to various fields of science and technology. His work in optics paved the way for the development of modern telescopes and imaging devices. His mathematical principles are used in fields ranging from physics to engineering. Kepler's interdisciplinary approach to science serves as a model for researchers and scholars, encouraging collaboration and innovation. The story of Johannes Kepler is not just one of scientific achievement, but also of human perseverance and the power of curiosity. Despite personal tragedies, religious persecution, and the limitations of the scientific tools available to him, Kepler's unwavering dedication to understanding the cosmos led to discoveries that continue to shape our understanding of the universe. Kepler's legacy is celebrated in various ways, from the naming of the Kepler Space Telescope to the numerous awards and honors that bear his name. His contributions to science are commemorated in museums, educational institutions, and scientific organizations around the world. As we reflect on Kepler's life and work, we are reminded of the importance of curiosity, perseverance, and the pursuit of knowledge. Kepler's journey from a small town in Germany to the forefront of the scientific revolution is a testament to the power of human potential and the enduring impact of scientific discovery. Johannes Kepler's legacy is a beacon of inspiration, guiding us as we continue to explore the mysteries of the universe. His work reminds us that the quest for understanding is a never-ending journey, one that requires dedication, creativity, and a deep sense of wonder. As we look to the future, We honor Kepler's contributions by continuing to push the boundaries of knowledge and seeking to uncover the secrets of the cosmos. In the spirit of Johannes Kepler, let us embrace the pursuit of knowledge with curiosity and determination, always striving to understand the world around us and our place within it. Kepler's legacy lives on in the discoveries we make, the questions we ask, and the endless quest for understanding that drives us forward. If you found this helpful, like, share, and subscribe for more. See you next time. It's Elliot, signing off.